Let's look at calculating relative atomic mass. And we're going to do so by looking at this mass spectrum. Now, a mass spectrum is a readout from an electronic instrument called the mass spectrometer. We will look at the mass spectrometer in more detail in another video. However, it is not required for the Unit 1 syllabus or exam that you know it in a lot of detail, and this is because it is done in the Unit 2 part of the syllabus. However, you do need to know how to read off a mass spectrum. A mass spectrum will show us a readout where on the x-axis it will show the mass number of each isotope for an element. So for your purposes, for Unit 1, in an exam question, if you see one, you will see a mass spectra for an element where the x-axis shows the mass numbers of each isotope. Now, instead of mass number in a mass spectrum, you may also be given a table showing relative isotopic mass. Either of these may be used to calculate AR. On the y-axis, we are supposed to see what is called the relative abundance. Now, the relative abundance gives us the percentage of occurrence for each isotope of that particular element. Now, relative abundance is supposed to add up to 100%. You can pause the video and check it to make sure that the relative abundance of each isotope when added gives 100%. You're also going to notice that the height of these lines, and I'm going to call it or call the lines peaks because that's the correct term, the height of the peak should represent the relative abundance. So this shows us silicon-28, this isotope, has the greatest abundance at 92.23%. Now let us calculate our relative atomic mass, which is the sum of the mass number for each isotope multiplied by its relative abundance. So this would be now if we add up all of these figures here, remember we are multiplying it by the percentage, so you have to make sure after having done the calculation that you divide by 100% in order to obtain your relative atomic mass. You can pause the video and do the calculation. After having done the calculation, you should get an answer of 28.09. Remember, relative atomic mass has no unit, and as a hint or a double check, if the most abundant isotope, or if there's only one, which is a very abundant isotope, such as silicon-28 with a percentage of 90-something%, this means the AR value should be close to this number 28, which it is. Right? So you have to be careful with calculations.